Hi guys, welcome to this course on NEET 2017, and yet again we are going to experience an amazing session where we are going to discuss some of the physics question that appeared in NEET 2017. And today we are going to discuss question number 36 to 40, and I am Vikas Joshi. So now let us begin for the day. Now the first question is, in an electromagnetic wave in free space, what is the medium? The medium is free space. Okay, the root mean square value, that is RMS value of the electric field, is ERMS, that is given as 6 volt per meter. The peak value of the magnetic field. Okay, so to solve, four options are given. To solve this kind of question, what we need to remember is the formula. The formula is more than enough. We don't have to apply anything special here. We don't have the hybrid concept. We are having the direct application of the formula. So all we need to know is the formula. What is the formula? I'm talking about this. This is the formula. Okay, C, that is the speed of light. C is equal to E naught, that is the peak value of the current the electric field. Okay, peak value of the electric field upon peak value of the magnetic field. The ratio of both this we get as the speed of light. So we know the speed of light 3 into 10 is power 8, and since ERMS is given as 6 volt per meter, so we can easily find the peak value of electric field. How can we find peak value of electric field? Is root 2 times ERMS. So if ERMS is 6, so E naught will become 6 root 2. So putting that value 6 root 2 upon B naught that we need to find will be equal to 3 into 10 to the power 8. That is the value of speed of what? Speed of light. Okay, so now again calculation is very easy. We need to find the value of B naught. That will become 6 root 2 upon 3 into 10 to the power 8, and upon solving that will come to B naught as 2.83 into 10 to the power minus 8 Tesla, and that is the first option. Now let us look at the second problem. Two disks of the same moment of inertia rotating about their regular axis, passing through the center and perpendicular to the plane of the disk with angular velocity omega 1 and omega 2, they are brought into contact face to face, okay, coinciding the axis of rotation. The expression for the loss of the energy during this process. All we need to do is the conservation part we will apply, and this problem is very easy to solve. Okay, so the situation is like this. These are the two disks that are rotating about their own axis. Let's say both are having because both are identical, so both will be having similar moment of inertia, that is I, and this one is rotating with omega 1 speed, this is with omega 2 angular velocity. Now if you are combining them, then the moment of inertia will become 2I, and let's say the net resultant angular velocity becomes omega. Okay, so now from the conservation of the angular momentum, we know that I omega, okay, I omega initial will be equal to I omega final. So initially we are having these two parts, I omega 1 plus I omega 2. Okay, finally what is happening? I will become 2I. So we will and since this have become a single system, so this will become 2I omega. Okay, from here I will cancel out. Okay, what will happen? We'll get omega as omega 1 plus omega 2 upon 2. Now the change in the kinetic energy, okay, the change in the kinetic energy will be seen as what will be the total loss. So we'll see what is the first rotational kinetic energy, that is initial, and we'll look at the final, and then we'll subtract both the terms and we'll get the what is the loss. So what is the formula for rotational kinetic energy? Half I omega square. So for this it will become half I omega 1 square. For this it will become half I omega 2 square. For this it will become half 2i, and omega net we have calculated, that is omega 1 plus omega 2 whole square. Upon solving this, we'll get this as 1 upon 4 I omega 1 minus omega 2 square. Okay, that is the first option. Now let us look at the next problem. The photoelectric threshold wavelength of silver is 3250 into 10 to the power minus 10 meter. The velocity of the electron ejected from silver surface by ultraviolet light of wavelength 2536 into 10 to the power minus 10 meter. H is given in electrovolts. Okay, and C is obviously 3 into 10 to the power minus 8 3 into 10 to the power 8 meter per second. Okay, so now there is something very special with this question. Now after solving that, you will come to know what is special with this. If you are carefully looking at the options, I am having the first and the fourth option are same, only like see, it is written 6 into 10 to the power 5, but it is written here 0.6 into 10 to the power 6, that is nothing but 6 into 10 to the power 5. So we are having two options that are same. So now let us look at into the solution to find whether these both are correct or some other option is correct, that is 2 or 3. Now let us look at the solution. Okay, so what it is given, that E is equal to hc by lambda, that is the basic formula. Okay, so what is the value of hc in electron volt? We already know, that is 1242. Lambda is given as 325. Okay, lambda is given as 325. This is okay, so we are going to put that value. Okay, so we will have E as 1242 upon 253.6 electron volt. This is the second part. Okay, and these two part we are talking about. Okay, this one and this one. So now this was the energy. Okay, and this was the threshold energy that we need to overcome. So the total energy will be anticipated into two processes, that is overcoming the threshold and gaining the sufficient kinetic energy. Okay, so what we need to find is the velocity. So we are unknown with this term, so we will shift this term here, so it will become E minus ETH. Okay, since now these are in electron volt, and we know that 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So this term minus this term will come as 1242 upon 253.6 minus 1242 upon 325 into 1.6 into 10 to the power minus 19 joule. That will be equivalent to half mv square. Mass of the electron is 9.31 into 10 to the power minus 31. Put the value of m, and upon solving we will get v as 0.6 into 10 to the power 6 meter per second, or in other language you can say that 6 into 10 to the power 5 meter per second. So in the examination both the options were correct. This was the bonus question. If you had attempted this, you will surely get the marks. Okay, so don't neglect the problem if you find it a bit difficult, and the problem was very easy, but we were having two solutions. Okay, now let us look into the next problem. A 250 turn rectangular coil of length 2.1 cm and width 1.25 cm carries a current of 85 microampere and subjected to magnetic field of 0.85 Tesla. The work done for rotating the coil by 180 degree against the torque is. Okay, so four options are given. Now there is a hint in this question. Okay, this is the rectangular coil. Any rectangular coil, tell me, in the presence of magnetic field, what does it behaves like? Okay, any current carrying coil under the magnetic field will behave as the bar magnet. Okay, so whatever be the work done, okay, to rotate a bar magnet against the torque, against any torque that is given, that will be same as the work done by the current carrying circular coil. So what is the formula for the work done by a bar magnet against rotating it against a torque? That is mb cos theta 1 from theta 1 to theta 2 angle. If you are rotating it, so the formula is work done mb is equal to mb into cos theta 1 minus cos theta 2. So we know the value of m, that is magnetic moment, that is nia. P is b from supposing that it is lying on this plane, so from 0 degree we are rotating it to 180 degree, so cos theta 2 will become 180 degree, and uh, I, A and B, all the values are given. Cos 0 is 1, cos 180 degree is -1, so this will become twice. Okay, turns are given 250, so I is also given as 85 into 10 is power -6. A is given, B is given, put the value, we'll get the answer as 9.1 microjoule. Okay, that is the fourth option. Now let us look at the last question for the day. The ratio of the wavelength of the last line of the Balmer series and the last line of the Lyman series. Very easy problem if you know the limits of Lyman and Balmer. Okay, so Lyman, Balmer, Paschen, bracket, P-Fund, Humphreys. We must remember the series. So Lyman is from 1 to infinity, Balmer is from 2 to infinity. So what does the basic formula says? E Balmer, energy associated with Balmer will be 13.6 upon this 2 square. Okay, 2 square minus 1 upon infinity square, that will become 0. So 2 square is 4. Okay, so 13.6 upon 4 electron volt, and for the Lyman it will become 13.6 upon 1 square, that is 1 only, so 13.6, and this E will be equal to hc by lambda. So this is lambda b for Balmer, this is lambda l for Lyman. Okay, now what it is asking, it is asking for the ratio of lambda b upon lambda l. So directly dividing these two terms and dividing equivalently these terms, will get the value of lambda b lambda l as 4, that is the second option. Okay, so this was the last question for the day. I hope you learned something and enjoyed the session. Thank you for watching. This is my link on Unacademy. Please do rate, review and share this video with your friends, because padega India tabhi to badega India. Thank you.